Hi. Give me a second. All right, I'm going to mute all of you. Okay, there we go. That kind of gets rid of all the echo. All right, so let me go ahead and share my screen so it's not just a, no. Just a random ceiling. So how are you guys doing?
I am good. I am just so ready for the semester to end.
Right, me too. I'm just
over it.
Same here. It's been so long.
I know. Do you guys go out at all?
No, my parents won't let me. They won't even let me order food in. That's
Oh man. I don't go out at all, but I do order food all the time, mainly because my husband likes to eat out a lot, so he'll order food. But yeah, I don't go out. I feel like I need sun sometimes.
Yeah, that's tricky. Sometimes I forget that we need that vitamin D and I just stay indoors all day.
Yeah, sometimes I make it a point to go outside and just sit in front of the sun for like 5-10 minutes, and then I'll go inside because I need it. Before I'd be out all day long, and now I don't go out at all.
Yeah.
All
I have a
right.
question.
Yeah.
So the final is going to be available from the 4th to the 11th?
Yes.
Okay, just making sure.
Yeah, because I know you have other finals, and I don't know how strict or how not strict your other instructors are. So in case you want to get my final out of the way, or in case you want to leave it to the end, it's up to you. And it's typed, so you don't have to worry about me not posting it because I'm not done typing it. It's typed. I got that out of the way, so just a matter of posting it.
Okay.
Yeah. All right, so from my end, I do have some work to do. I do have to grade your homework so that you can see a grade for it and see where you stand. I do have to grade your test 3 so you can see where you are there. I will try to get that done between today and tomorrow. I'm thinking today, but I mean, something always happens, so I get caught up. When I don't want to work, I start cleaning. So I might start cleaning the kitchen or cleaning the bathroom. So for the off chance that happens, let's say today and tomorrow. All right, so let's go ahead and begin. Let me share my screen. We're going to go over section 7.6, the law of cosine. I think this chapter 7, it's really fun. I really like working with these triangles. I think there's something different than the right angle trigonometry. All right, so 7.6, solving oblique triangles and law of cosines. Introduction. When the given information for an oblique triangle is either side angle side or side side side, and what I'm saying by these things, they always used to trip me up when I was a student. I was like, what does it all mean? Side angle side and side 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 refers to what's given. Side angle side means that in order you're given a side, an angle, and a side. And side 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 means you're given all 3 sides, right? There's no angles. So that's what that means. And there's a lot more to it, but essentially, if it's side angle side or side side side, we are therefore by default forced to work with law of cosines. Because law of sines, as we read in the next line, the law of sines cannot be used to solve for the first unknown value. There's not enough information to use law of sines. There's 2 unknowns, so that's why it wouldn't work. This is because we do not at first know both an angle and a measure and its opposite side measure. So for example 1, if we're given the measures of sides B and C and the included angle A, we get side angle side. So this is your side, your angle, and your side. 2, if we are given the measure of all 3 sides, we have side, side, side. So we have a side given, another side, and the third side. In either case, our first solving option will not use the law of sines. Once the first measure is found, either the unknown side or the unknown angle, the law of sines may be used to solve the other missing parts. I want to cross that out because there's a really big exception to that. So, and we'll talk about this. I think it's in the next page. Before we consider any examples or applications, let's first develop the law of cosines for side, angle, side. We will also develop the law of cosines for side, side, side. All right, I'll do only one of them, developing the law of cosines for side, angle, side. And if this just doesn't really click, it's okay. It's just telling you, hey, what do we do to get these formulas? If it just seems too weird, you can just take the formulas for given. That's forgiven. As given, not forgiven. They don't apologize. As given, and we can just use them as a rule. All right, moving forward. The law of cosines can be developed using any oblique triangle by first drawing an altitude from the largest angle vertex to its opposite side, forming two triangles. So that's this dotted line here. These right triangles are separated as shown on the next page in triangle 1 and triangle 2. To develop the law of cosines, we find cosine of A in triangle 1 and use Pythagorean theorem to find both triangles. All right, so in triangle 1, we get to find angle A, it's made up by cosine of adjacent over hypotenuse, so x over c, right? So remember that's adjacent over hypotenuse, which is x for adjacent and c for hypotenuse. All right, so if I want to solve for the side x, that would be c times cosine of a equals x. All right, the Pythagorean theorem for each triangle. For triangle 1, it would be x squared plus h squared equals c squared, right? This is a leg. Ooh. We have a leg, and your hypotenuse. So x squared plus h squared equals c squared. The Pythagorean theorem for triangle 2 would be your leg. So it would be b minus x squared, and your other leg plus h squared equals a squared. To develop the law of cosines, we use equations 1 and 2, and they're numbered right here, equation 1 and equation 2, and equation 3 to eliminate both x and h. Let's first expand the equation 3. All right, so here we want to work it out. So we're going to start out by multiplying that square, that b minus x squared. All right, so if we multiply that out, we get b squared minus 2bx plus x squared plus h squared equals a. All right. Now we're trying to work out these three equations that come from the same triangles and try to fit them to what we have so far. All right, so we see that we are here. We're left with b squared minus 2bx plus x squared plus h squared equals a. On the left side, we have x squared plus h squared, and that can be replaced by c squared. Because isn't c squared equal to x squared plus h squared? All right, let's go ahead and do that. So we're going to replace these with just a c squared. All right, so we're left with, oh, that's h, not the b squared. Let me erase that. All right, so we're left with b squared minus 2bx plus c squared equals a. Now from equation 1, we have c times cosine of a equals x. We will now use equation 1 to replace x with c cosine of a. So this x here will now be c cosine of a. Now the equations in terms of the original triangle ABC. Rearranging the equations in terms, we get the first form of the law cosines. So this is one of the formulas. It was developed so that with using two triangles, you can come up with only the exterior parts of the outside triangle. All right, so that's how side angle side was made. Side is much shorter since you kind of have the developed two triangles. If everything I said just went in one ear and out the other, it's okay. It's okay because for our purpose, we're mainly going to use the formulas. These are the formulas, so you can take them as given. My sisters like to call during lecture. I'm sorry about that. All right, so here are your formulas. They're given to you in two ways, but they're the exact same formula. One of them, so here, this is when the side is unknown. So if you're looking for side A, trying to find side B, and trying to find side C, this is the formula to use. Now, this is the exact same formula that you have on your right. They're the same, but some algebra is being done to rework it so that you don't have to do it yourself. So if you're looking for an angle instead, this is your formula for when you're looking for an angle. Now this is very cool. Let's take a look at the first set of the first set of formulas. Let me erase this. All right, so notice that for each formula, it kind of works out so that you're only working with two sides and the angle, right? So here, this lengthy formula only has me working with two sides, and we recycle them here as well. And then I have one angle. And that's how they all work. We're working with two sides and an angle that doesn't belong to the sides. And then we're working with side, side, side. Our formulas, if you look at them clearly, all of our formulas are made up of only sides, right? If you cover up this side, I can't see my hand covering it, but if you cover the side that says cosine A, cosine B, cosine C, and just look at your formulas highlighted in red, they're made up of only your sides. So we use only the sides to find some other angle. Now, we're going to do an example, and we're going to do the same problem twice. The reason for that is because law of cosine has a problem, an issue that you may encounter. It's not a big deal. There is a way to go around it, but it leads us on to the next section that we won't cover. But it's just getting us ready for that. So let's go ahead and do example 1. Example 1 tells us, given that angle A is 52 degrees, side B, we know it's a side because it's a lowercase b. Side B is 15 inches. And side C is 8 inches. Solve the triangle. So we see solve the triangle. This means I want to know what is angle C. We also want to know what is angle B. And we also want to know what is the side of C. I'm sorry, side of A. All right, let's go ahead and work this out. So using law of cosines for A, we can go ahead and find side A. We have an angle C. So if we use our formula properly and choose the right one, this one works out. A squared is equal to B squared plus C squared minus 2BC cosine A. Now, how do we know this is a formula we want to use? Two reasons. One, we can't use law of sines. We can't use law of sines because if I wish to use law of sines, I would have to have a known angle and its opposite, well, and its corresponding side. I don't have A, so I can't use law of sines. So I would look to my law of cosines. And because this is a scenario where I have side, angle, side, by default, law of cosines will work. Yeah? All right, so we have our formula. We're going to use A squared plus B squared. A squared equals B squared plus C squared minus 2BC cosine A. So let's fill in our pieces. We have them listed right below. B squared is 15 squared plus C squared, 8 squared, minus 2 times 15 times 8 times cosine of 52. All right, so make sure you take the effort to punch into your calculator. Make sure you're in degrees. When I was making the video for you guys, it takes a lot of effort because it's never the first run through. It's like 10 run throughs before I get to one that's worth uploading. Make sure you are in degrees. One of my takes, when I got to that problem, I punched in my calculator. I knew it was wrong. And I was like, damn it, I'm not in degrees, I'm in radians. So make sure you're in degrees. If I can make a suggestion, first do cosine of 52, get an answer, then multiply and work out your remainder answers. So the way I would punch it in is I would do cosine of 52, get an answer, leave it in your calculator stored, then multiply that by 15 times 8 times 2. All right, we're gonna subtract, right? So attach a negative to it. Or you can multiply the other parts and then subtract it. Depends on how your calculator works best. All right, so what I'm gonna do next is then do 15 squared plus 8 squared and then bring back my answer. So minus answer, and your answer should be 141.24. But remember, that's square. We want A, not A squared. So take the square root of your answer. You'll get 11.88 for 449,603. You run around to one decimal place, so 11.9. All right, so we found that A is 11.9. All right, now I need to find two more angles, right? Angle B and angle C. Angle B and angle C. Now I only need to find one of them because if I find one more, to find the last one, I just subtract from 180. One more step to do. Now that we have the value of A, we can use it to help us find one of the unknown angles. SOHCAHTOA is not an option because we don't have a right triangle, but the law of sines is. So the law of cosines, and so is the law of cosines for the angles. Let's find the largest angle B using law of cosines. Now, this highlighted phrase will lead us into example 1, part 2, which is an error. Okay, so let's find the larger angle using law of cosines. So we have this information, we have this formula. Let's go ahead and find angle B. This is the formula we want to use because our answer is an angle that we want to find. We're choosing the largest angle. That's why we're starting there first. It's your largest angle. All right, so we found A. A is 11.9, but when you're working with an answer that's a long decimal, put in as many decimals as you'd like or can, because it would create a better answer. If we round, our answer might be different because it's already rounded within. All right, so A squared is 11.8845 squared plus C squared, which is 8, minus B squared, which is 15, divided by 2 times A times C. All right, this is calculator work. Make sure you can punch into your calculator. You should get negative 0.10392, but we still have that cosine. So remember, to undo cosine, we do cosine inverse to just get B. So B is cosine inverse of negative 0.10392, and our answer is 95.96. If we round, it's about 96 degrees. So B is 96. To find our third angle, we just simply subtract. We do 180 minus 52, which was given, minus 96, and we get the angle C. We get the angle C is 32 degrees. So we have solved the triangle. We know we have solved a triangle when it have all three sides and all three angles. Okay. Now in part B, I highlighted a line there that says, let's find the largest angle using the law of cosines. So law of cosines has a potential error. All right, let's take a look at example 2 from example 1. All right, let's go ahead and use A. A, find angle B using the law of sines in this information. So it's taking part triangle B. It's taking the part from example A using the same triangle. Maybe use the same sine formation or angle formation. A, B, C. A, B, C. And it's telling me that side B is 15, like example 1 said. Angle A is 52. And now it's telling me that side A is 11.8845. That's what we found for example 1, right? Now your question is, find C. Well, we already worked out C, right? So why are we doing it again? We know that C should be side C. Oh, we're looking for angle C, right? Oh, it's telling us C is 8. I got ahead of myself. And it's saying that C is 8. We're going to find angle B using law of sines. All right, so this is our unknown. When we used it in the first example, to find B, we used law of cosines, and we got 96. Now we're going to use law of sines. Based on the given information, use the law of sines and a calculator, find angle B. Use the measures of angle A and side A as the right side fraction for part B, and compare the value of B here to the value of B in example 1. All right, so we have law of sines. All right, so we have this formula. We have sine of B over 15 equals sine of 52 over 11.8845. All right, we multiply both sides of 15. We take sine inverse, and we get B is 84.6. 0.0354. Is this the same as B in example 1? No, right? B in example 1 got 96. Using the law of sines, the calculator gives us B to be 84 degrees. However, this contradicts the value of B equaling 96 that we found in example 1 using law of cosines, which is correct. B equals 96 is the correct answer, because the domain restrictions on inverse sine functions are between negative 90 to 90. The calculator only gives us an acute angle measure when using inverse sine. In this case, the calculator gives us a supplement of 96 degrees. What's the moral of the story? If possible, avoid using law of sines on an angle that might be the largest angle in the triangle. Or my suggestion, when using law of cosines, stay with law of cosines. Yes, you can be extra careful and make sure that if you're trying to find an angle, make sure it's always the largest one, and you use law of cosines. But that can be kind of hard to keep track of. Or it might be easy to forget when you're taking an exam or working through your homework. So when you're using law of cosines, stick with law of cosines. If you throw in law of sines, it must be to the two smaller angles. When you get to a largest angle, it creates a supplement. So it gives you 180 minus what you want. Now, this leads us to the next section that works with how many triangles are we working with. Yeah, we're given an image and information for one triangle, but maybe there's two, or maybe we get some contradiction and there's no triangle at all. Let's read from our text. In general, there are two unknown angles in a triangle, side angle side or side side side. And enough information is known, then we can apply the law of cosines to either unknown angle. And two, we should apply law of sines only for the smaller two unknown angles. Or you can just stay with law of cosines. Okay, let's do an example. Given side A is 3.5 centimeters, side B is 4.9 centimeters, and side C is 2.5 centimeters, solve a triangle. Round each to the nearest tenth. All right, so let's take a look at our triangle. Now, the reason why I'm asking this is because notice you have three different side measurements. If you want to perhaps use law of sines, which your question does, you have to make sure you do the largest angle with law of cosines. So we have three sides, 4.9, 2.5, and 3.5. The largest angle produces the largest side. So therefore, out of these three numbers, 4.9 is the bigger one. It's a larger side. Therefore, angle B is the larger angle. So make sure you use law of cosines on the larger angle for the case that it is over 90 degrees, because if it's over 90 degrees, it's going to give you the supplement. So let's go ahead and do law of cosines on angle B. All right, based on the strategy suggestion in the previous example, let's first find angle C, the smaller angle, using law of cosines. Okay, we can do that too. So cosine of C equals A squared plus B squared minus C squared over 2 times AB. It's just calculator work, so make sure you're okay with punching it in and getting the answers. You should get 2.9. Now let's use law of sines on angle A, the other smaller angle. All right, so we found angle C is 29. And now I can proceed with law of sines, but I have to make sure it's not the larger angle. All right, so we have sine of A over 3.5 equals sine of 29 over 2.5. So we get sine of A equals 3.5 times sine of 29 over 2.5. We apply the sine inverse, and we get A is about 42.7. So then we subtract to get B is 108. Okay, do you try it? Let's go ahead and get it sorted out first. So we have a triangle ABC. Is that what the book is using? ABC, yeah. And we have that side A, lowercase a, is 4 yards. We have side B, lowercase b, is 7.5 yards. And C, lowercase c, side C is 8.5 yards. Solve the triangle. Okay, so I have all 3 sides. I'm left to find the remaining 3 angles. Now I need to only find 2 because the third one can be found by subtracting 180. I need to keep track of my largest angle because I want to make sure that I do log cosines with that, or if I'm avoiding log cosines, use log sines of the smaller ones. So I just need to keep track of my largest one. My largest side is 8.5. Therefore, my larger angle is C. And it's just worth keeping track of because I know it can give me trouble. All right, so I'll give you about 3 minutes to give this a try. I'll stop you at 2:48. So go ahead and get started. All right, let's go ahead and regroup. So you had total liberty to start whichever way you wanted. We just kept in mind that C was our larger angle. So that means that I want to be aware of that because I do not want to use law of sines on angle C. That would produce an error. Maybe. Depends on if the angle is more than 90 degrees. So I'm going to start with law of cosines. If you started somewhere different, that's okay. Your answers will be the same. So let me know if you get a different answer. All right, so I'm going to use law of cosines to find C. So to find C, I have a squared, which is 7.5 squared, plus b squared was 7.5. A squared was 4, b squared was 7.5 squared, minus c squared, 8.5 squared. All over 2 times a, my a is 4, and b, 7.5. All right, let's punch that into our calculator. Now, as I'm punching this in, want to make sure you put your numerator in parentheses, division sign, and your denominator in parentheses, just to avoid a silly mistake. All right, so I have 4 squared plus, make sure it's on, 4 squared plus 7.5 squared minus 8.5 squared. That give you 0? Do it again. 4 squared plus 7.5 squared minus 8.5 squared. Oh, we get 0. It doesn't matter what the denominator is, but eight times 7.5, 60. Can you guys hear me?
Yeah.
Okay, just making sure we didn't have an incident like last time. Cosine of C. We take cosine inverse to find C. So C is equal to cosine inverse of 0, which we all know the answer to by just like punching it in. We get 90. So C is 90. Now to find the other two angles, we have a cool case. Why is it cool? We have 90 degrees, right? So if you want to, you can use SOHCAHTOA for this one. But let's use our new tricks. I'm going to continue with, what do I want to continue with? You have so many options. Well, you have SOHCAHTOA, you have law of sines, law of cosines. Since law of cosines is new, I'm going to use law of cosines again. All right. So I'm going to use law of cosines to find angle B. So to find B, I have cosine of B is equal to a squared plus c squared minus b squared all over 2ac. Let's fill in those pieces. A is 4 squared minus c squared, 8.5, plus 8.5 squared, minus b squared, 7.5. All over 2 times a, which is 4, and times c, which is 8.5. All right, let's go ahead and get a decimal. Let's punch that into our calculators. I have 4 squared plus 8.5 squared minus 7.5 squared divided by 2 times 4 is 8 times 8.5. We get 0.4705. 0.470588. Do cosine inverse. So B is equal to cosine inverse of 0.470588. Let's punch that into our calculators. Second cosine, 0.470588. You get 61.92. Let's round to 1 decimal place. So B is about 61.9. All right, lastly, to find this third angle, we do 180 minus 61.9 minus 90. We get 28.1. And you solve your triangle. Now you could have done it many ways. You could have done log cosine to find one angle and then use log sines for the rest, as long as it wasn't the larger side. All right. There are some word problems here, and we're going to skip them. The reason for it is because we're in a pandemic and because we're running kind of tight on time, I am not going to give you a fourth exam. Rather, I'm not going to give you another exam. I'm just going to give you a final. So your homework will be numbers 1 through 8, I believe. That's what I was thinking of doing. 1 through 8, yeah. Oh,
Professor, really quickly, we're not doing section 7.4, correct?
7 point what?
7.4.
Didn't we do that one?
Might have
think we
missed it, but
did.
I didn't see a video for it.
7.4? Have notes on it, so maybe we did a video. I didn't post a video for that one. I'll take a look. Maybe it's a mistake from, well, of course, if it's up there, it's my mistake. I'll go ahead and post it if I have it. It should be in my recordings. Oh, I'm sorry about that. I'll make sure to make it available.
Or it's not a big deal. Thank you.
Yeah. All right. So that's all cosines. I think it's really fun. I really enjoy it. And I think it's a nice place to start. At least you got all the trigonometry basics. So now the only thing that's left for this course is your final. As you go on to your next course, make sure you remember how to use your unit circle and how to graph. Those are the two main things you'll see in pre-cal. I think in pre-cal you spend most of your time doing college algebra all over again. So I don't know, make sure you look through those concepts that you learned, like logarithms, exponential equations, inverses, functions, matrices. Pre-cal is, you do a lot. You basically do courses in one to get you ready for calculus. So you should like it. All right, so that's it for the class and for this day. If you have any questions, feel free to email me. I'm still available via email. If you need to talk to me, or rather just ask me in person, we can always create a Zoom meeting. It's not a big deal. Just say, hey, I would rather, can you offer office hours? And I'll be like, yeah. And we'll set up a time. It's not a big deal at all. I'm here for you. Just because we're done with lectures doesn't mean that I'm just gone. I'll be around. I'm always attached to my computer. So just talk to me. Let me know if you have questions or if something is a problem. We can definitely sort this out. Just try to get it sorted out sooner than later, because class ends on Thursday, not this Thursday, but next week Thursday. then I have to get grades out. So make sure you ask me, ask your classmates, get your questions answered. Don't feel like you're alone and I'm gone and it's all on you. No, I'm still here. Just ask away. Alrighty? Cool. Thanks, Crystal. She put a thumbs up. Alrighty, so I'm going to go ahead and leave our meeting. I'll post it on YouTube soon. Maybe like an hour, half hour, and then I'll check Sal to see where 7.4 is. And we read a note, 7.4. So that I can upload it in case, since I didn't. Alrighty, any questions before we take off?
No.
Alrighty. Okay.
Sounds good.
Well,
Have a good one, Professor.
thank you. Have a good one too. Bye. Stay safe. Don't go outside. Not until numbers go down, no matter what they say. Until number goes down, that's when things get better. Okay? Be
Bye.
patient. Bye.
Yeah, I will try.
Bye.